Hopefully, you've started to see that chemistry is an interesting and complicated topic. It turns out that to understand the world around us and the role chemistry plays in it, we need to sometimes use really big numbers, and sometimes really small numbers. To do this, we use something called scientific notation. So in this lesson, we're going to learn how to express big and small numbers with scientific notation. Let's take a look. So here on this first slide, we have an example of a really big number, the distance across a galaxy, which turns out to be about 587 quadrillion miles. And when you write it as we ordinarily write numbers, we call that standard notation. And it's a lot more convenient to express these big numbers in scientific notation. So if we express that same distance in scientific notation, we can see that it takes much less space. And instead of writing all those zeros, you see this times 10 to the 17th thing. And what that's basically saying is you're going to multiply 5.87 by 10 17 times, and that's how you can get a really big number. You can also use scientific notation to talk about really small numbers. Say you want to know how far it is across the hydrogen atom. Well, you can also measure that, and if you write it down in standard notation, it's a bunch of zeros and then a 1/6, a really small number. Similarly, we can write that number in scientific notation, takes up much less space. The key difference here that you should notice is that before we had a positive exponent, that's the number above the 10, and now we have a negative exponent. It's very important that whenever you see a negative exponent in scientific notation, that's telling you that number is really small. So always keep that in mind. What we're going to do in this video is we're going to go through a few examples of taking things back and forth between scientific and standard notation. So you're going to learn how to start with the number down here on your left and go to the number on your right. So our first example is going to take the number 3400, which is currently written in standard notation, and then write it in scientific notation. I've summarized this process in 4 steps below. So the very first step, step 1, says move the decimal until there's only one number in front of it. Now, 3400, you can see, doesn't have a decimal explicitly written, and that's pretty normal. But if there's not a decimal written in your number, it's always just at the very end. So that's the number 3400 decimal place at the end. Now, we want to know how many times we need to move that decimal until there's only one number in front of it. So step 1 is we're just going to bounce this decimal over to the left 1, 2, 3 times. So our decimal ends up there. Notice that only the 3 is left in front of it. So step 2, we're going to rewrite that number and we're going to add a times 10 to it. So we're going to write 3.4 because remember we've moved our decimal. You could write those 2 zeros next. If you do, that's not wrong, but it's not necessary either. It's just taking up space. So we're going to drop those 2 zeros and we're going to put a times 10 there. Okay, step 3. Step 3 says count how many times we've moved our decimal. So we've moved it once, twice, 3 times. And so that's the number you're going to write in your exponent, the number above the 10. So we're just going to go over to our 10 and we're going to write a 3 above it. Okay, step 4 says, if the decimal was moved to the left, you're done. So notice in our example here, we have in fact moved the decimal to the left. It started over on the right, and now it's to the left. So we're done. 3.4 times 10 to the third is just 3400 in scientific notation. Okay, so now we're going to do another example where we start with a number that's small. 3400 was big, and now 0.0073 is small. And we're going to see that the steps you follow are just slightly different. The only real difference is in that last step, step 4. Okay, so again, step 1 says move the decimal until there's only one number left in front of it. And when I say number, I really mean non-zero number. So we're going to bounce this decimal over again once, twice, 3 times. So we've bounced our decimal over 3 times, and now we're going to go to step 2. And step 2 just says rewrite that number with a times 10 behind it. Again, in this step, we're going to drop those zeros. These zeros that come out front don't change the number. I can add zeros in front of a number and it doesn't change it. So we're just going to start by writing 7.3. Now remember, we've moved that decimal. That's why the decimal point is now between the 7 and the 3. And we're going to add a times 10. Now, we want to count how many times we've moved that decimal. Turns out we've moved it once, twice, 3 times. So that's what we write in our exponent, a 3. Okay, last step. We just did step 3. Last step here, step 4. If the decimal was moved to the left, you're done. If the decimal was moved to the right, we need to add a negative sign. And you can see here, in this case, we've actually moved our decimal to the right. And since we've moved our decimal to the right, we're going to add a negative sign in front of it. Remember, that negative sign is really important. Whenever you see that negative sign, that means your number is really small. So that's taking a number from standard to scientific notation. Now, we're going to do 2 examples going in the other direction. Now we're going from scientific notation, that's what we start with, and we're going to go to standard notation. Once again, we have 4 steps here. So the first step is we're just going to rewrite that number. Step 1 is just rewrite that number without the times 10. So we're just going to write 3.75. Step 2 says, if the exponent was negative, we're going to bounce that decimal to the left. If the exponent was positive, we're going to bounce that decimal to the right. And here we can see that there's no negative sign in front of the 5. And so that means we're going to bounce the decimal to the right. And that makes sense because that's going to give us a really big number, which is what we know we have when we have a positive exponent. So I'm going to bounce that number over. How many times? 5, because that's the exponent in my number in scientific notation. 1, 2, 3, 4, 5. So now our new decimal ends up right here. And what we're going to do is we're going to fill in those bounces with zeros. That's step 3. So all we're going to do is wherever we have a bounce, we add zeros. So we've actually now regenerated our number in standard notation, but it's a little messy because of all those bounces. So step 4 is we usually just rewrite that number without all the mess. So what we're going to get here is just 3, 7, 5, followed by 3 zeros. Okay. So that is taking a number from scientific to standard notation. We're going to do one more example of scientific to standard notation, and this time we start with a number with a negative exponent. Again, that means right when you look at that, you should think, oh, that's a small number. That's what the negative exponent is telling us. Okay, once again, 4 steps. In step 1, we're just going to rewrite that number without the times 10. So all we're going to do is we're going to rewrite 2.73, and we're going to drop that times 10. Now, step 2 here says, if the exponent was negative, bounce the decimal to the left. And so you'll notice that there's a negative sign up here in front of the 4, and that means in this case, we're going to be bouncing the decimal to the left. So we're going to bounce it to the left, and we're going to do that 4 times. 1, 2, 3, 4. And so now our new decimal ends up right here, and we're going to add those zeros back in. So that's step 3. Step 3 says fill in the bounces with zeros. So we have 1 0 here, 1 0 here, and 1 0 here. Again, at this point, we really have our number back in standard notation, but we want to rewrite it just to make it a little neater. So that's step 4. So step 4 says we're going to rewrite it to make it neater. And what we'll do is we'll put point and then 3 zeros. 2, 7, 3. Now, it's customary to just add an extra 0 in front of that decimal. It doesn't change the number, but it helps us keep track of that little point, that's a decimal point. Otherwise, some people might look at that and say, is that an intentional decimal point or not? So you usually just add a 0 there right in front of that decimal. Doesn't change the number, but just makes it look a little neater. Okay, that's it. So we've talked about how to go from scientific notation to standard notation, and also how to talk about how to go from standard notation to scientific notation.